Hey everybody, I just wanted to send a quick review video on Punnett squares and pedigrees. I know there's a lot of questions about this still. Looking at the review questions, there were some that weren't quite clear. Not that people aren't getting it, but that it's really hard to write good Punnett square, especially dihybrid crosses Punnett square questions. So I wanted to make sure that everybody really understands these things. So let's first start with pedigrees and how you can tell if a gene is recessive or not just from a pedigree. So if you have a situation where, like in one of the questions we had, we were asked to draw in the assignment on pedigrees, you're asked to draw a pedigree. Remember, a pedigree is a tool for tracing traits in a family, and you're asked, you're told there are two sisters, so then you're asked to draw the parents, mom and dad, and then their parents. So here's mom and dad, and then mom and dad. Can you see that? Yes. And then you were told that we have? One sister, the dad, and the maternal grandmother all have freckles. Okay? So whenever you draw a pedigree, you always have to draw a key so that you can say what is what. If I were to just look at this and I said, so one sister has freckles, the dad has freckles, and the maternal grandmother has freckles. Okay, so now I have to have a key. So if I were to look at this without any text, I could say, okay, if it's colored in versus if it's open, what does that mean? So in my case, I said colored in means you have freckles, and open means no freckles. All right, cool. So now how do we figure out what's recessive and what's dominant? Well, recessive is always masked by dominant. So if you have a single copy of the dominant gene, you cannot see the recessive trait, at least in the simple Mendelian genetics that we're doing right now. I know it may not seem simple in the complicated crosses, but trust me, genetics gets much more complicated than this, so just trust me. Okay, so recessive means it's masked if anything else is present. So this is key. These parents and this kid are the key here, so that you know freckles must be recessive. So we're going to call that little r, because F's are hard to distinguish. So how do I know this must be a recessive gene? Well, if either of my parents here, the paternal grandparents, had freckles, they would show the trait, right? They would be colored in, but neither of them do, but their kid is. That means that both of these must have at least one dominant gene and one recessive gene. Okay, so how do I know it's not the reverse? So this would then be RR. If this was reversed, if freckles were dominant, the kid would either be big R, or big R, little r, and they would have to get a big R from one of the parents, but then the parents would show it. And so since neither of them show the trait, it must be masked by the other gene, which means it must be, the freckles must be recessive. Okay, awesome. So that's done. So now we have determined that if that's little r, this must be little r, this must be little r. Cool, so what is everyone else? Well, this mom must have at least one little r because she had one daughter that's got a little r, but she doesn't show freckles, so she must have a dominant, okay? So that means that this girl is going to have, the only thing that she could have is a big R and a little r, because if these two parents, if we do their Punnett square, and that's where these two things come together. So we have little r for dad, big R, little r for mom, so this must be big R, little r, little. Those are my only two options. So this sister must be big R, little r. Okay, cool. So then what's this dad? Is this dad big R, little r, or is it big R, big R? We actually don't know, and it doesn't matter. So you could actually just write it as big R space or big R question mark. Okay, yeah, because we already figured out everything else, to have one final parent or grandparent that's open is not a big deal. So hopefully that helps with the the pedigree part and figuring out what's recessive and what is dominant. Let's talk about the Punnett squares. Specifically, I wanted to talk about dihybrid crosses. So this is a single trait cross because there's only one thing being crossed by another thing. So we're just looking at freckles or no freckles. Okay, so that's one gene with two alleles. Okay, so no freckles is either going to be big R, or big R, little r. Done. Okay, and then the presence of freckles is little r. Cool, we're done with this. Let's talk about another. So someone wrote a question that, there's a couple questions that were interesting. and I wanted to talk about how their crosses worked. I think there was some typoing going on in here. There were some typos. So one person's question was, if you have short hair versus long hair, then long is dominant, and short is, nope, I put that wrong. This is hard. So short, no, actually I did it that right. Okay, so let's try again. Long is dominant to short, so they were denoted as this. If they didn't give me letters, I would make up my own letters. And then we're told that brown is dominant to orange hair. Brown, and then little b, orange. All right, cool. So, and then it asked, what if both parents are brown, they're homozygous. So we're told both parents are homozygous. It's G4, brown, and long hair. All right, cool. Is it brown, or is it brown and orange? I think it might have been brown and orange. Nope, that doesn't make sense. Orange and long. Orange and long hair. I don't remember. Let's just say we're told that both parents are homozygous for orange and long hair. So what must that be? So homozygous means they have to be two of the same. So that means if it's orange, it's little b, little b. If it's long, it has to be big L, big L. So the fact that we're told that it's homozygous tells us that this must be big L, big L. The fact that it just told us orange tells us this must be little b, because you wouldn't get orange unless you had two little b's, because again, that's the recessive or the masked gene. So then the question is, what are the chances? I don't know what the question is, but let's just draw the Punnett squares. Let's talk about what's the chance of having a kid. Chance of kid with orange and brown hair. Nope, orange and long hair. Hello. I don't remember. The question, I think, was worded kind of interestingly. So we know this cross is big L, little b, times big L, little b. So what are the only kinds of gametes I could get out of this? You know the gamete is going to have one L and one B. The only L's present are big L's, and the only B's present are little b's. Okay, so that's the only thing that can happen. Okay, so we'd actually just do this once even. The only ones here, again, are big L, little b. Basically, if you were to draw the big 16 by 16 chart with all of these, you would see the only combinations possible are big L, little b. Okay, so we're actually, because that's literally the only genes present here are the big L's and the little b's. That's it. A more interesting, and it's not a bad question. It's just what's happening in this one. So a more traditional question that you see with these kinds of things is if you have heterozygous. So somebody wrote a question that said, if you have a gene that gives you loud sneezes, and that's dominant, so then I'm going to draw the Z with a cross for the dominant version, and the big Z, and then little z I'll just do regular. So this is quiet sneezes. Interesting. I like it. And then you have long necks versus long neck is dominant to a short neck. Maybe these are giraffes. And you cross two heterozygotes. So if you have heterozygotes, that means you have big Z, big G, little g. Cross with big Z, big G, little g. Cool. So what are the possible combinations that we could get of the Z's and the G's in this? We could have big Z, big G. We could have big Z, little g. We could have little z, big G, or we could have little z, big little g. Because that means in each one of the versions of the gametes that could be produced, we have to see how many combinations of Z's and G's do we get. Well, we have to have at least one Z and one G. We could only have one Z and one G in each one, so we would end up with that. And the exact same thing would happen here. Big Z, big G, little g, big G, little z, little g. So now, this is where you would draw the big, crazy Punnett square. Still see this? Yes. Boop. So, this is the 4x4 Punnett square. It's giant. It's intimidating. Some people are really good at this. Some people are not. So I'm going to show you the secret way if you don't remember. So I'm going to do all across the top. I'm going to do big Z, big G. Then I'm going to do big Z, little g. Little z, big G, little g. Same thing. Big Z, big G. Big Z, little g, big G, little z, little g. And then you cross them. So big Z, big G, big G, big Z. I'm going to pause it while I do all this. I don't think you need to listen to me fill it in, but you should go ahead and fill it in too. Okay, magic. It's all filled out. Okay, so now you would have to go through and like count your different kinds of genotypes. Depending on what the question asked, it might say, what are the chances of having a quiet sneeze but a long neck? So what are the chances? What's the probability, or what are the chances of an offspring with quiet sneeze, long neck? Okay, because those are both advantageous if you're a giraffe. So that you would have to think, well, what's quiet? Quiet is going to be little z, but long could be either big G, or big G, big G. So then you have to go through and count every time I see two little z's and some big form of big G. So there's this one, there's this one, there's this one. Are there any more? I think that's it. So 3 out of 16. I could be missing some. It's very easy to miss stuff when you have this really big table. Okay, so it's a lot easier to break this up into two single trait Punnett squares. So what do you do then? And you can do it either way. You get the exact same answers. Do what works for you. So to do it, if this thing intimidates you, especially if you start to lose letters, you can break this up. So let's do it again. We have big Z, big G, little g, cross with big Z, big G, little g. And I'm actually going to break this into big Z, cross with big Z, and big G, cross with big G, g. And let's do two simple Punnett squares. So big Z, big Z, and then this big G, big G. So this is big, little, little, big G, big, little. So what was my question? My question was offspring with quiet and long neck. So quiet was little, so this is 1 out of 4. Long neck is 3 out of 4 here. Okay, so we decided up here we got 3 out of 16 squares. Cool. Well, if you do two little ones, which took all of like 3 seconds, you just multiply the chances. So then again, we get 3 out of 16. Same answer, because it's the same thing, just done in two different ways. So you could do these this is a dihybrid cross, these two cross Punnett squares in two different ways and get the same answer. So do what works for you best, okay? Keep track of your genes and make sure you know recessive is the masked chromosome or the masked allele, and good luck on your test. Bye.